Hello YouTube. In this video we're going to do something kind of interesting. Specifically we're using this video to use the formal definition of the derivative to find the slope of a graph at any point and just kind of practice using that formula. But we're going to use it to find the derivative or the slope of a line at any point x. And the interesting thing here is, when we consider this graph here, actually I've written a graph, we say f of x equals negative 3x plus 5. So we could necessarily fathom this in our heads, but we'd go up 5, 1, 2, 3, 4, 5, we'd have a y-intercept here, go down 3, right 1, and there you have it. We'd have this entire locus of points right here in this line. Anyways, looking at this, we say, okay, so let's find the derivative of it. Well, recall that the derivative of a graph is the slope of that graph at a given x value. And so the thing about a line is this: it just has a constant slope. Constant slope. That is, every time x goes up by 1, y goes down by 3. We'd have a table that would look like this. We said we had a y-intercept of 5, but then we go over 1, down 3. Go over another 1, we go down another 3. And so what you see here is we get this constant negative 3 rate of change. As a matter of fact, this is what we call the slope. If you look at the equation, we say that the m value here is our slope. The fact of the matter, though, is that it's never going to change its slope. So if we were to find the derivative of this graph, okay, then it should always be negative 3 if one considers it. And actually, I've graphed this in GeoGebra. I just want to show everybody this here. We've got a point A on this line, negative 3x plus 5. I slide it back and forth, but what I want to demonstrate here is this. If I were to drop a tangent line on this now, so it says select a point, so select point A, and then select the line I want it to be tangent to. I click on this line, which is our blue graph. You notice it kind of just went gray a little bit here. There's our blue graph there, but put in the tangent line, and let me turn off the blue graph here, and oh, that's point A. Blue graph is off. So what you see is now this new tangent line to the original graph, and you notice that it is the original graph, okay? So if the tangent line has the same slope as the graph at any point x, then we know that this tangent line has the same slope as any x value on our original graph. And so we should get, when we do the derivative, negative 3 for all points x. But let's just go ahead and show this. Okay, so recall that the definition of the derivative is this. We say given some f of x, if it is continuous, then we say f prime of x. Okay, so f prime of x. So f prime of x. Okay, and this is our derivative function, and it is the slope derivative function. Just to remind everybody here, and it is the slope of the original graph. We define f prime of x as this, where they say the limit as h goes to 0 of this expression, f of x plus h minus f of x all over h. And so what we need to do here, first of all, is we need to find f of x plus h. Keep this in mind. We already know f of x. F of x is negative 3x plus 5, and h is just h. So let's find f of x plus h. So f of x plus h. We can do this work up here, but we say that'd be negative 3 times blank plus 5. And what we're putting in the blank this time happens to be this quantity x plus h. So we'll just kind of float this over here. So we say f of x plus h equals negative 3x. We'll go minus 3h plus 5. So we get this expression right here. And this is actually going to have to go back into our limit down here for this f of x plus h term. So we get f prime of x. A little bit of rewriting to do in this section. We say limit as h goes to 0 of f of x plus h, which was this expression from up here. We'll put it in right down here. We say, okay, this minus f of x all over h. So we get negative 3x minus 3h plus 5. And then on the right here we say just f of x, which was negative 3x plus 5. So, let's go ahead and do our distribution of our negative here. This is going to make this positive, make this 5 negative. And when we combine like terms, I want you to notice that this negative 5 on the right and the positive 5 on the left, they cancel each other out. Okay, and then on the right here we have a positive 3x, and over here we have a negative 3x. And this happens a lot, actually, but these cancel out. You notice the thing that's left on top is this expression including all h's. So we say, okay, so this expression we're working with right now, right here, becomes the limit as h goes to 0 of this. The simplified form would be the negative 3h left on top over h. And what happens here, our h's cancel, and certainly what you get is this. Okay, so the limit as h goes to 0 of -3. And if you remember, there's just a law. It says the limit is h, say it goes to c of some expression b, where b is a constant. You just get that constant value. So in this case, we get the limit of -3 is just -3. Okay. So what I want you to understand is, this right here, this is f prime of x. That's what f prime of x equals. And so if I wanted to find, say, the slope of our graph, we can go over to GeoGebra here, like when x equals 1, what's the slope of my graph? We can pick this up here, slope right there, and we say, what's the slope of my graph right here at x equals 1? Well, what we'll do is we'll take our function here, our derivative function, which is this bottom right one. We say, let's go find f prime of 1. And the nice thing about f prime of 1 is you just get -3. The fact of the matter is, if I don't have an x value to plug in this 1 for in the first place, then it's always -3. It's this horizontal line, -3. So basically, we're saying everywhere on this graph it has a slope of -3, but that makes sense when one thinks about it. And this was good practice using the definition of the derivative to find the derivative first, and then use that to plug in an x value to see what we get for a slope. So cheers.